Hi everyone and welcome to this presentation. GraphQL is the new PHP. My name is Lupin, I'm 22 years old and I've co-founded Lupin & Homes, a company that we're running with my brother. And I've been doing bug bounty hunting on HackOne for the past 4 years, something like that. And today we're going to talk about GraphQL security and even compare it with PHP security. So why do I love GraphQL? I hate it. I actually hate it. But why do I hate GraphQL? Because it's slaggy, it's complex, and I never understood what is a subscription operation anyway. But that's all the reason why it's my favorite target, because my comfort zone can be the same as other people's comfort zone. And if I try to go outside of my comfort zone, maybe I'm going to find a new area of research, new vulnerabilities that other people might not have found. So that's why GraphQL for me is the best target. But okay, what is GraphQL anyway? GraphQL is meant to be an query language for APIs, where basically you can describe the data present in your database and then request them, but only the data that you want. For instance, if you have a project name namsec, then you can request only the tagline, and this is exactly what you are going to receive. GraphQL is meant to be an ever-evolving API endpoint where basically you do not need the versioning anymore and where the client can request only the data that they want. In GraphQL, there is certain type of operation. There is the queries, where basically is meant to search and fetch data. The mutations are what in REST is the delete, the put, and the post, where you create, delete, or update any kind of data. And then there is the subscription operation, which is basically meant to fetch data, but when the data are evolving over time, where they can change over time, and basically you create a long-lasting connection with the GraphQL server through the mean of a WebSocket, for instance, in order to see the update in the data. So basically, subscription is like some kind of query of a WebSocket. Let's talk about my recon process to identify a GraphQL endpoint. So I could use burp or Kaido, put a rule, and every time I see a GraphQL, try to dive in. But I really like to just hunt on GraphQL lately. So basically what I did is I put a lot of the domains of different targets and try to identify only the GraphQL endpoints. And for that, I created a script, pattern code that will open an headless Chrome and then hook all the XHR requests until a timeout that I've set. I think I've put between 2 and 5 seconds for each page. And then if one of the XHR requests match one of my rules, then it's a GraphQL. And so my rules are if the body is a JSON and contain the query field name, or if there is a mutation in the body, then it must be GraphQL. Or if it's a GET request with a query as a parameter, then it could be GraphQL too. I could, as I say, I could use also nuclei or any other GraphQL endpoint identifier, but I had a lot of false positives, and these techniques really gave me a lot less false positives and more pertinent results. So I'm quite happy with this technique. Once I identify a GraphQL endpoint, my goal is to try to see if there is an introspection. That's the first thing I do. An introspection is an operation in GraphQL where you can basically describe all the schema of the data, all the operation, all the mutation, subscription, fragments present in the GraphQL schema. This is like a swagger that will be updated automatically and that is present natively in GraphQL. So introspection is really interesting if you want to have like the entire documentation of how to interact with the GraphQL endpoint. And once I have an introspection, I go to GQL Spection. This is the tool that is a successor of the really famous InQL. And basically it allows you to enumerate all the requests possible for an introspection, all the requests that you can do to the GraphQL backend. And this is where we are going to find maybe undocumented calls. By the documented, I mean present in the JavaScript so that you can read. But with an introspection, maybe you are going to have calls that are not present in production or stuff like that. So it's really interesting. Okay, so now you have a GraphQL and check for introspection. But the introspection is forbidden. Yes, because you can disable introspection, which is actually one of the best practice in GraphQL security. But don't worry, you've watched this talk and you know exactly what to do when introspection is disabled. Basically, GraphQL doesn't want you to fail and will actually help you to find all the fields name correctly with something called the field suggestion. And so each time that you put a keyword that is really close to a keyword present in the schema, then it will prompt you give you an error. Did you mean, for instance, update user detail? And that behavior, we can fuzz it with a tool called Clairvoyance. Clairvoyance basically is a tool where you input a word list and then it will fuzz all the keywords present in your word list until it matches a did you mean response. And from the did you mean, it will try to reconstruct an introspection schema on a JSON format, and it's recursive. So each time it finds a field, it will then fuzz all the different, each time it finds a queries, it will fuzz all the fields present in that queries. Same thing for mutation and all different operation, and everything is recursive. Something that you need to be mindful when using this tool is it's the request per second. This tool sends a lot of requests per second, and I already managed to do a DOS on several targets just by sending this tool. So you really need to be mindful of that, and also the number of threads. The threads are more like for if you want to have the best result possible and not false negatives. And then be mindful of the quality of your word list, and that's always super hard to have a great word list. And so to have a good word list, there is one tool that will really help you when doing GraphQL security, and this tool is called JS Weasel. Basically, JS Weasel is a JavaScript IST analyzer. It will parse the JavaScript code as a tree and then provide you an instant overview of the code. Of course, it's a commercial tool, so might not be suitable for beginners to invest in this tool. But there is an alternative, open source alternative coded by the amazing Tom Nom Nom called JS Loose. I hope I pronounced that correctly. And this tool is completely open source, but it requires more custom code and advanced setup. So if you like to dig in Golang code, this is basically the best alternative for you. But basically my usage of JS Weasel is that I go find all the GraphQL queries, mutation and operation that it found, and then I will use the feature to generate a word list out of all the queries that are already present in the front end. By doing that, I know that I'm using the words that the schema is using because it's already present in some queries, and so I might find new queries and reconstruct the entire introspection, and maybe also find undocumented field names and operations. So it's really the perfect match with Clairvoyance. Okay, so now that we have an introspection schema, what do we do? Here are some techniques and real world stuff that I found on my bug bounty journey. The first target, I found this name funny because it's flying inside the cuckoo's nest. You will understand why. The context, my target had multiple organization with multiple users, where basically the company was handling credit cards, right? And each user had a role from viewer up to super admin, but only the admins could view the balance of the credit card. And so, of course, we had an introspection, so all good so far. And my goal was to see if there was a permission error from a viewer, if they could see the balance of the credit cards. So I sent the credit card query operation and tried to get the balance amount, but of course it was forbidden, and the error was this user can't query the operation credit card, which is super interesting because it doesn't tell you, you can't see the amount of the credit card, which is the business rules behind that. It says that you can't send the credit card query. So what if they put the security on the queries, but not on the final object that you want, so the balance amount? Okay, let's try something out of this. I created a tool specially for this target called introspect.py. I wasn't really inspired by the name at the time. And basically you provide an object type that you want to leak or to have a privilege escalation to. And we are going to search it inside the introspection and search all the different routes possible from queries mutation that could leak this object. Here's an example. I know we don't see a lot of things, but here's an example of this tool running on the hackathon.com GraphQL introspection. They enable introspection. It is known, it's not a vulnerability, don't worry about that. And basically here I ask for the activities user completed retest object, and it finds all the mutation queries possible to access this specific object. So now we have all our different routes. Maybe we can find a vulnerability where our object is nested inside other queries and other objects. And this is exactly what happened in this privilege escalation, where basically through organization, account, then balance overview, account balances, available balance, you had access to the amount object, and you could see the amount of the credit cards from a viewer. So that was a cool privilege escalation. That was treated as a medium vulnerability, but depending on the context, it could be treated as high or even critical if you can leak PII data. But the technique is really interesting. Target number 2, where subscriptions are finally useful. Okay, how do people can do bad security in the GraphQL realm? Basically, where you have a client saying JSON, and there is a web application firewall reading the JSON, and then if everything's good, sending it through the GraphQL server. But the thing is, you do not want to put the check of introspection at that level, because for instance, if the client sends an introspection and the WAF blocks it, but the GraphQL still enable introspection, this is really bad practice to do something like that. Why? Because for instance, if there is another protocol, let's say WebSockets, where you can send the introspection instead of subscription, you send a query with the schema introspection, then the GraphQL could validate it. There is some GraphQL that through WebSockets, you can do all the other operation, not just subscription, you can do normal operation. It is kind of weird to do that, but some backend GraphQL enables that. So each time that you have a GraphQL, let's see if they enable WebSockets and they know it. And if you have a web application firewall that doesn't allow you introspection, maybe through WebSocket it will do it. And so WebSockets are so cool because you can just send your WebSocket and bypass it. Here is an example of JavaScript code to do it, to bypass web application firewalls rules. This could work also for SQL injection, stored XSS, or any kind of injection that you want to do that could be blocked by a WAF. So if you have a web application firewall with the GraphQL, let's try that and see what happens. But there is another cool vulnerability called cross-site WebSocket Hijacking. My French accent is horrible, sorry for that. Where basically this vulnerability is like, let's say, the CSRF of WebSockets, but the only difference is that you can also read the response. And in order to have this vulnerability, you have a few requirements. The first one is that the authentication is solely cookie-based, and then that during the exchange of the protocol upgrade, for instance, each time that you open a WebSocket, it will first send to the server in HTTP and then upgrade the protocol with a 101 response that will switch to a WebSocket. And so if they implemented the CSRF header at this level, then it's not vulnerable. And even if they don't implement a CSRF header and you have cookie-based authentication, be careful that you do not have an exchange of a secret or JWT token right after the authentication. I already had a target where I thought it was vulnerable, but it was sending the JWT token right after connecting to the WebSocket. And so I couldn't guess that cross-site, right? So it wasn't possible to exploit it. But on this target, it was quite funny because we had everything to be vulnerable, and you could just send a mutation through the WebSocket to, in this context, was to decline an invitation, so it was medium. But again, you can read the response for that, so you could leak PII data depending on the scenario. So every time that you see a GraphQL, check if they enable WebSockets and cookie-based authentication, and see if you can have a read-write. It's basically like a CORS policy vulnerability, but here directly on WebSocket. So it's really interesting vulnerability too. Okay, here is the third target. Forgot to say that this technique I was given by this book. I needed to do a shout out of this book, Black Hat GraphQL. Amazing book for GraphQL security, written by Nick Alex and Dolev Fahri. Again, hope I pronounced that correctly. Anyway, I needed to do a shout out because this technique was from this book and gave me a pretty good bounty. So I needed to tell that. They are amazing, and so if you want to go into GraphQL security, check that book. And so here is a technique that I discovered, which is basically a widespread vulnerability within GraphQL. So basically this target was a bit different because here the query, you could search for a secret within the organization or the user account. And basically the search was like if it's match a sub-word of the secret, it will still provide you the value. So you could just enumerate all the secrets in plain text. And so the first thing I tried was to transform that to a GET request and see if it works. And yes, it worked on Burp. You could send a GET request here. However, when I wanted to go on Firefox or Chrome, I had a message not allowed. So why does it work on Burp but not on the browser? And the reason why is because the browser send and accept text HTML, and for some reason the backend wasn't allowing this specific header. I don't know why this backend was behaving like that, but if you change text HTML to text plain, it would work. However, we can't send that just by clicking a link. We will need to make the user visit a link that will then open an XHR request. So it's still possible in one click to have a CSRF. However, there was an XCSRF header for mutations. So I could only do get queries, but I couldn't update or create data on the account. And because it's a CSRF, we can't read the response in this context. Okay, so let's find another way to exploit this behavior. What do we have here? We have an SOP bypass through XShare because I then changed the get back to a post. But when you have a content type of text plain, there is no course policy, and the same origin policy will not trigger an error. So you can send post request through text plain. And you can also change the accept header to text plain because accept is an header that is authorized by same origin policy to be sent cross-site. So we have like some kind of SOP bypass here because the GraphQL server still understands where it should trigger an error when you send a different content type. Cool. So we have cross-site queries working. But what can we do with that? Remember, I said at the very beginning, GraphQL is so laggy. And so what I tried is that to create some kind of denial of service condition where I would use GraphQL aliases to repeat the same operation in one request more than 10 times. And what was funny is that when it matched a secret, it was taking more than 1 second and a half to answer. But when the secret wasn't matching, it was taking 200 milliseconds. Okay, so wait a minute. We can send requests cross-site, and we have a way to discriminate when we have a secret or where we don't have a secret. Isn't that the perfect scenario for cross-site search or excess search? And yes, it is, because we have a search engine returning confidential data. We have cross-site requests working, and this huge delay to GraphQL being laggy. So the first thing that I did when I had everything confirmed was to check, is there like a GraphQL research on excess search? And actually there was only one result on Google, but they only the company that did this research didn't provide a proof of concept, only said that it was possible and it worked on a couple of targets. But I wanted to have the proof of concept. So everything good so far. I started coding at 7 p.m. my proof of concept. Then at 4 a.m. I was crying in the bathtub listening to Billie Eilish. And then at 5 a.m. the proof of concept was working. So how does it work? Basically, the search engine could match chunks of 4 characters, and it will retrieve the right secret. So what I did is that I created different chunks, and then I queried character by character until it was matching a chunk. And then I do something called sliding the chunks. I don't know the real word for it, but for instance, if it was matching A, B, C, D, then I will take the end of the first chunk that was matching and put it back at the beginning of my second chunk, and then D, E, F, G. And that way I can link chunks and at the same time brute force character by character the secrets that I wanted to retrieve. And so for each check of leakage, I sent many times the same request, and I was logging the average time because, for instance, if the user had bad Wi-Fi, the excess search condition was like returning a lot of false positives, and I didn't want that for proof of concept. And then for each query, I wanted also to have to send a 404, something that will trigger a 404, and that I know that the secret can't match that. Why I wanted to do that, it was because I wanted to compare that to my average time and just say that if there is enough difference, then I know that my check it was confirmed and that it's not a false positive. And I did a lot of random mathematics because I'm really bad at math until I had something working on different computers and different type of connection. So let's recap this vulnerability. We had a GraphQL get-based request. Then we managed to use that as an entry point to bypass the same origin policy, so we can send a request cross-site. Then we used a famous denial of service condition through GraphQL aliases to create a big response time when our search result exists compared to our search result not existing. And then from the JS, we can leak secrets of a user. And also, I didn't sleep and cried 3 times. But yeah, this vulnerability was really cool and helped me secure a $26,000 bounty. So really, really interesting vulnerability. And I'm sure that it is more widespread than we think. Every time that you see cookie-based authentication and GET requests, and that you can send the content type, for instance, in text plain, you might have a vulnerability, a CSR vulnerability. But if you don't have a CSR vulnerability, try to make the response time bigger in order to leak with an excess search. Well, thanks a lot, everyone, for this presentation. This was a different type of recon, different techniques that I use when I'm hacking GraphQL. I hope that you liked it and have an amazing rest of NahamCon. Have a good day. Bye-bye.